Welcome everyone. Today we are talking about building interactive tool with the MCP Elicitations, and MCP is already becoming an important protocol for connecting AI system with tools. But today we are going beyond simple tool calling. We will explore how tools can ask the user for missing context, confirm important action, and create better human in the loop workflow. With me today, Ashwin is here. Ashwin is developer advocate at Redis. Ashwin works around AI, system agent memory, MCP patterns, and the practical product engineering. Today, he will walk us through how MCP elicitations can make tools more interactive, useful, and reliable. But Ashwin, before we jump to the main event, I have a question to ask.
Sure.
MCP is getting a lot of attentions right now. Some people say it is overhyped, some say it is an API wrapper, or some have a view. What is the real problem developers are trying to solve with the MCP today?
Yeah, that's a great question. So, I think the real problem that developers are trying to solve with MCP is not about how do I wrap one more API. It's about how to make agent tools work in real workflows where your prompt could be incomplete or the request could be ambiguous or the action could be risky for that matter. So APIs are great at one-shot interaction, one-shot transactions, but they don't have a layer that enables them to pause mid-execution, like on the protocol level, or they don't have a way to ask for the missing information or continue in the same flow. I think that is where MCP becomes useful because it gives agents, I mean, and also developers a protocol layer for making tools more than just a thin wrapper around your APIs, but also making them more interactive instead of just being transactional. So,
Thanks, Ashwin. That gave us the right context. Let's move into your presentation now. Please share your slide and walk us through the topic in your own flow.
sure. I'm
Then,
just sharing my screen.
yeah.
So, hi everyone, and thanks Rajan for having me in your podcast. So, my name is Ashwin, and the title of this talk is Building Interactive Tools with MCP Elicitation. So MCP is having a very real moment this year. The spec is continuing to ship thousands of community build MCP servers out there, and if you notice around you, like every IDE, every chat host that you've been using for a while, like ChatGPT or Gemini, all the tools that you're familiar with and you're using every single day, they're all racing to add MCP support. And there's a good reason for that, because Agentic AI now has this protocol layer to connect with external systems. Um, but you've also seen the counter takes. MCP is just an API wrapper, or MCP is overhyped. I was at MCP Dev Summit in Bangalore and Mumbai, and I was asked a similar question over there as well. So it makes you wonder whether those takes have a point. It largely depends on how you use this protocol, and that's what this talk is going to dig into. Um, we're going to look into how MCP can do something which APIs fundamentally don't, which is to be interactive and involving humans in the loop and augmenting the user experience. Uh, yeah. So, quick introduction about me. So, I'm a developer advocate at Redis. I work on AI systems, agent memory, agentic AI patterns in production. And my background is in full stack development. So in this talk, I'm coming at MCP from a very practical product engineering angle. So how to build tools that feel interactive and useful. That's my goal in this session. So yeah, here's what you'll learn. First, the landscape, the baseline model of building MCPs, which is just a substitute for APIs. And then talking about why we need a different mental model. Then we'll go into what elicitation actually is, the mechanism, and then I'll show you a demo of how it looks like. We'll cover a few workflow categories, ambiguous input, missing context, authentication flows. Then we'll talk about the architecture. How does the implementation look like in agentic AI systems? Why the schemas look the way they do, and how does MCP elicitation work for external systems? And finally, how you can get started, and what's the best way to get started with this? All right, so let me set. Yeah,
No, that's great. That's great. Please go on. I was
yeah,
just
okay. So let me set the stage a little bit. So I know we are all like building. For those of you who are watching this podcast, I mean, we're all building MCP servers, or at least trying to build and learn. That's what most of us are here for in this podcast. Clients connect, servers expose tools, and agents invoke them. So that's what it's a pretty clean way of doing things. But also, you would have seen the counter takes, like I said mentioned earlier. MCP is just the API wrapper. Um, that criticism can be fair when MCP is being used as just a thin layer over a REST endpoint. In that case, yes, it is really an overhead. You're adding complexity to get something that a regular HTTP call could give you for free. Now, the thing about APIs itself is APIs are usually, you can think of it as just being one shot. Request goes in, response comes out. That's it. They have no way to pause mid execution and ask the user something. No human in the loop. At least when I'm talking about that, I mean in the protocol level. So that's
yeah.
a fundamental limit of how APIs are designed. They're transactional, uh, not conversational, right? So MCP gives us ways to add human in the loop, and elicitation is one of them. And we'll look into how that works. So here are a few scenarios. Let me just get a little bit concrete. So let me show you what goes wrong if an MCP tool is just being used in the sense of just being a thin wrapper around a REST endpoint. So the one shot pattern is pretty straightforward, right? Agent picks the tool. It's going to fill a bunch of arguments from whatever the user has said in the prompt, and it's going to fire off the tool, and it's going to get a result back. Done, and move on. That works best when the agent has all the information that it needs. But often, it doesn't have that, right? Here, as you see in my screen, these are the examples of three different scenarios where sometimes the prompt is not enough. Take a schedule meeting tool, for example. The user might say, set up a design review for Friday at 2 p.m. Okay, you have the time, but which calendar? Is it work calendar or is it personal calendar? And who's invited? The prompt doesn't have that, at least yet. Or think of a book flight tool where the user says, I want to book a trip to Japan. And then the agent is going to invoke book flight tool. Sure, but then what city? Is it Tokyo? Is it Kyoto? Is it Osaka? It's still missing, right? Or let's say you have another tool where the user wants to send an email, so the agent has access to a send email tool. But when they say send someone an update, but maybe there is no recipient in the prompt. You might have two people with the same name, or what is the email address? Who do you send it to, right? So these are a few scenarios for which now prior to MCP elicitation, what would be the standard way of handling these three scenarios when the input isn't enough? Here are some options. All of them are not so great options. So option A is just to guess. The agent picks a value out of thin air. It may book a flight to Tokyo because the user said Japan. Maybe Tokyo is right, maybe it's not. The user might find out after reaching the airport, I guess. um,
Yeah.
Option B is like, the second option is just failing, right? The tool returns an error. The agent will surface that error back to the user as text. Like it would say, I could not book your flight. So the user now has to retype the prompt with more information. Hopefully, they have to guess what was missing this time. Some of these tools, they give these reasoning steps, so you can actually see them, like what's happening, and then maybe you can figure out, okay, maybe this was missing, and then you can give it. But you don't really want that's kind of leaving the hard work to the user to do it. They have to figure out what went wrong and not. And option C is, just bounce back and then just keep looping. The agent doesn't call the tool. Instead, it bounces the question back to the user, which city in Japan. That seems fine. That seems similar to what elicitation is. But then it's gonna pose that question back to the user as text. It sounds similar to elicitation, but elicitation it's not very structured. This bounce and loop is not very structured. The agent is going to ask the question again in text, and then the user has to again answer back by typing a response in text, and then the agent has to spend tokens to re-extract that answer from the response, and then again it has to call the tool, new tool call, right? So it's spending a bunch of tokens, right? It has to reason through what the user has said. So new tokens, so context is resetting, and if more than one slot is missing, the agent is going to loop through that cycle again, for each slot, so it can go wrong. Like, honestly, none of these are very great. Probably option C seems to be the status quo at the moment, right? At least for most of the tools that we are currently are the ones that we are using. So the model right now, so it's been right input, right output, wrong input, wrong output. That's the default we carry over from the request response APIs, right? Like, the API is successful, it returns a 200. If it's wrong, then it just gives an error. So that's the standard way we think about endpoints for more than 2 decades now, from REST. But now we're trying to move past this REST APIs, and the goal is broader, So can we collaborate with users mid execution? Can we pause and ask in a structured way? That's the key thing. Tools that can negotiate when something is unclear instead of just failing or just guessing. That's what we're after. All right, so MCP elicitation, let me sort of unpack the mechanism. So here's what MCP elicitation does. So it gives tools a bidirectional protocol so that the server can negotiate with the user mid invocation without the client having to retry. So it gives a server a way to pause the tool mid execution and ask the user a typed question. Right, so it will be typed. There will be a schema, and once the user has filled in the missing details, then can resume with the missing details. So the tool's promise resolves once the user replies. Same session, so there's no replay. Now, if you compare that with the bounce and loop, it kind of feels similar, but it's not really. The bounce and loop option is where the agent asks the user in natural language, not in a structured way, and then it has to re-extract the answer from the follow-up message that the user gives. Okay, so with the elicitation, the difference is we're not sending back a text response. The server is asking with a schema, actually, and then the response is coming back typed. Okay, so the tool then resumes. So there is no context reset, and there is no tokens burnt re-extracting the answer. And the other advantage is that the schema is what allows the client to what the client uses to render a user interface, whatever client the user is in. It could be Claude Desktop, it could be Gemini, ChatGPT, doesn't matter. And the client can render the schema in the form of a UI. It could be a form, it could be a chip cards, it could be a drop down message, it could be voice prompts. The server does not dictate the UI, it just tells this is the shape of the schema. Now it's up to you, however you want to display it in a structured way in the user interface. Yeah. So we'll look into that in the demo and the architecture section as well. Now I want to talk about specifically where there are 3 categories where this workflow kind of really shines. One is ambiguous input. As I said, so the user said something, but the tool cannot pin it down. Japan could mean any one of 5 cities. Plan a trip can mean a lot of things. many things can go behind planning a trip. Like it could be searching for places, or it could be things to do to explore, or it could be like what things you want to pack maybe like before the trip. So planning can involve so many activities. So ambiguous input, missing context, the user didn't say enough, maybe the tool needs more before it can proceed. And then the other one is like, authentication flows. Sometimes the tool needs permission, access to a calendar, a payment authorization, something where it's kind of like you don't want to let the tool just kick off a set of process without actually explicitly asking for permission. Like, am I allowed to do this or not? Right? So three categories where elicitation really pays off. Now let me show an example before I jump to the demo. I want to show you how this looks like in its absolute simplest form. So you can imagine a tool that runs shell commands, on the server. Some shell commands are safe. Ls is a safe command. Pwd, that's still fine. You don't want, so you don't really need to elicit the user. Can I run ls? So pwd is also fine. But some commands are destructive. Let's say rm or kill, shutdown. So for the destructive ones, let's say you want to confirm with the user before proceeding. So here's an example of how you could define a tool that uses MCP elicitation before it proceeds with executing that command. So on my screen, this is using LangGraph.js tool helper to define a tool called make run command. Okay. And the MCP's SDK's server.elicit input, that is for the actual elicit call. So the heart of this piece of code is in 3 lines. So one is you will read the input over here. If you can see my pointer. So you will read the input and check if it's destructive. Okay. If it is destructive, then call a server.elicit input with a confirmation schema. So notice that it's not just a text response. There is a schema that it's adhering to, and there's a shape for the schema. Okay. Once this happens, the tool will pause actually, and then the client is going to surface that schema back to the MCP host. Okay. To the user. That's where the user will see it. Now the on the user side, they might see it in the shape of a radio button, or a toggle, or however the host decides to render the schema.
Yeah.
And the user might select a yes or a no based on the whatever they see in the screen. And then the promise will resolve with action and content. Okay. So if they accepted and confirmed, then run the command, or else return that it's been rejected. The user does not want to run this command. So action can be one of 3 things over here. I'm checking if it's accepted or not. Action can be accept, decline, or cancel. Okay. And content can be the typed data shaped by the schema, right? So that one tool, one schema, one Boolean response. Simple. This is like the hello world of MCP elicitation.
Yeah.
Yeah, when I show you the demo, I'm using a slightly different pattern at the graph level because there's a multi-node graph and parallel tool calls and so forth. But yeah, and if you're using Python instead of LangGraph.js, you are most likely using FastMCP for building your MCP server. So FastMCP also currently exposes an API. It's called, so you can import context. So from fast MCP import context, and then you can call context.elicit. So that's available in Python as well. So yeah, now let me show you what the more complex flow looks like. And before we look at code or discuss the nuances, of the protocol itself, I think it's useful to know what difference it makes to the end user. I think I want to approach from that angle. Like first, we'll see there's a clear pattern of a UX improvement and how it
Yeah.
enhances the experience, and then I want to work backwards to the actual architectures. That's what I think that would really make this more concrete. Okay, so
Okay.
here, so this is my demo. If you can see my screen, it's a trip itinerary builder. All right. So now you can see, as soon as I type hello, the system knows that it's a trip planning agent. The user is most likely wanting to plan a trip. So it's asking, how can I assist you today? And are we planning a trip or looking for some recommendations? So, but then the tool does not know, the tool can't proceed. It doesn't know where the user wants to go. So it's eliciting a bunch of destinations. And these are actually enums. We'll come back to the schema later. So these are the list of cities that my system, my AI agent currently supports.
Okay.
So let's say I pick Delhi for now. Okay,
Yeah.
and then it doesn't know when I want to travel as well. Okay, so it's asking, are there any specific dates that I'm planning the trip for? Let's say I skip this part for the moment. I'm not going to give this intentionally, I'm not going to fill this information. All right.
Yeah.
Now notice that my agent is also asking for my preferences, like what am I in the mood for, and it's already
Right.
selected a few for me. Like if you notice,
Mm-hmm.
where did this come from? So it comes from long-term memory. We'll go into that in detail towards the end. But basically, that's one pattern. So elicitation works best when the agent has the necessary context. So having a memory layer is super important production. So that way, the agent can elicit what is not already known. Um, right? So it's already selected a few because it gauges from my past interactions that these are the preferences that I usually have. So let's say I pick like maybe one more. Let's say I pick outdoors as well, and then I'll leave the start date like just intentionally blank for now, and I'll hit continue. Okay. Um, so now the agent has all the necessary context, and it's going to plan my trip. So what it's doing is behind the scenes, it's going through my database to look for list of points of interest, and it's giving me a list of candidate cities, like a candidate
Mm-hmm.
places where it knows that these are my preferred places that I want to visit, based on my interests. Right. So I have like all these different places over here. So let's say it still doesn't know when I want to plan. So notice that right after it surfaced me all these bunch of responses, but now the only missing information is just the date. Like that's what it needs to really come, like sort of complete the, that's what it needs to thoroughly plan my itinerary. So it doesn't know that yet. So notice that before we started in the beginning, it didn't have lots of information, but now this time it has some information. It's missing only the date fields, right? So it's only now eliciting for the date picker. It's showing me a date picker so that I can fill in the the dates that I planned for the trip. And it's not showing the rest because it already has the necessary information, right? So now let's say I pick maybe I want to travel during August. So I'm
Yeah.
just picking August 10th to 17th, maybe let's say, and I'm hitting continue.
I mean,
Um,
that's the
Now,
duration you've given.
yeah,
Okay.
yeah. So now I've picked the dates. So my agent now has some more context. And now, if you notice that it's my UI has been updated finally the with the dates that I plan to travel during my trip. So let's say I can pick now, let's say these three places, and I can see on my map what is um, my start destination, and this is my second, and then I'm ending my trip over here. So the map gives me a visual cue of how my trip path looks like. So let's say for the sake of this demo, we'll just add three places for now, and then I've updated it. Okay. and I've
Okay.
asked my agent to add these places to my trip. So it's applied, and then it's thinking through what is the next step. Notice now that each time we have this interaction with the agent, it's also
Mhm.
asking these follow-up questions. Again, this is based on, now it knows that it doesn't need any extra information to actually plan. But then my system also knows that usually at this stage, maybe the user wants to know what things to pack for. Maybe they want to see some other options as well. So my agent is able to smartly elicit optionally these options as well. Like, it's not super critical important, but it's making a very, very educated guess as to what might be the next question to that the user might have. So this
And
way I can avoid typing, and I can
yeah,
just click what should I pack.
and
Right.
somehow it's also giving the idea to the user what I
Yes,
mean what they can quickly ask by just the click instead of typing.
exactly.
Yeah.
Yes, exactly. So the one of the good parts about having elicit, a very smart elicit elicitation is, if you are using mobile devices. A recent study by Grammarly shows that I think that when people use mobile devices, they tend to make a lot more typos compared to a desktop user,
Yeah. Yeah.
because typing with just like thumbs are is it's not, it's very tricky, right? So and it takes more time. So this way, with having a smart way to elicit responses from the user, allows for a much better user experience. With just one single tap, the user can continue having this flow of conversation through until they've planned, until they've just done their task well. So so yeah, these options will keep changing from time to time, like find outdoor activities, find more food spots. All right, so now what I was showing is, this is form mode, by the way.
Hmm.
uh, the date picker and the initial list of candidate cities and the preferences, that is one way of a mode of elicitation called form mode. Okay, so far we've seen form mode, which will handle ambiguous input and missing context. Pretty straightforward. Now,
Hmm.
let's say if I want to do something different, I want to save this trip to my Google Calendar. Now, the
Hmm.
tool needs permission to access my Google Calendar. Like, it needs to have OAuth credentials to actually do that. Now, how do we do it?
Hmm.
Uh, the obvious move is to just show another form, maybe where the user can enter their email and their password, perhaps.
Yeah.
Right? So just pop another form, input two input boxes, one username, one password, and ask the user for their credentials. But we should so the can we really should we really do that? Can we ask the user to type in their Google password into a card? So that's kind of a security, that could be a security risk. Okay, so the
Mhm.
MCP spec, they actually saw this coming. So form mode is kind of explicitly discouraged for anything to do with credentials, for secrets, for OAuth tokens, for payment information. So what do we do instead? We use another mode which MCP Elicitation provides. It's called URL mode, where the server will return a URL, and then the client is going to open the URL in a browser. And then the user authorizes on the real provider's domain, not on ours. And then the callback flow, once the permission has been provided, the callback flow flows back to the server, and then the tool resumes. So let me show you an example of how that looks like. So let's say
Okay.
I've now added these three places. Now I want to add it to my calendar. Okay. Yeah. So what happened once I typed save this trip to my Google Calendar? So
Hmm.
what happens is my agent fires a URL mode elicit. So it's returning a Google OAuth URL, and then once I click on opening, give it OAuth access,
Hmm.
it opens this URL,
Okay.
right? So now I can authorize it on Google's domain. Okay, so I'm gonna do that exactly. So let's say I click here, and then um, Yeah, because it's not a published app, so it's asking me that I want to run, I want to allow it access or not. So let's say I hit continue, and it's done. So now what will happen is the callback will get fired in a bit, and the tool will resume and write my events to the calendar. And it will give us back a URL which we can go to, and we can actually view the event. So it will give me the link to the actual event.
Oh,
So yeah, so I'm gonna open this. I need to make this UI the URL clickable on the chat box. But let's say I open this. Oh, sorry, not open. Yeah. So let's say I click this. And then you can see it's added the trip to Delhi, and it's added the places as well. Yeah, you can make it more sophisticated. Of course, this is just because we're just looking at an example. So we just kept it fairly simple. Just add the itinerary details, but you can do a lot more. And then yeah, it's added some bunch of good information over here, places to visit. But yeah, you can make this more sophisticated if you want, like get the Google Map details of all these places and add them as well. So you can go crazy. And then it's marked it from August 10 to 17, which is the dates that we selected, right?
yeah.
So now, so that was it for the uh, both the modes we saw, like form mode and then the URL mode, right? So the design choice for the URL mode is to make elicitation secure at the protocol level. That's worth thinking about, so this is one of those moments where a spec is trying to, because MCP is getting really popular now, they want to intentionally prevent a class of bad designs, and just discourage, encourage good designs, right?
Yeah.
Yeah. So, okay, now we've seen the demo. So let me show you what is under the hood. For those of you who are watching this podcast, might be curious, what did I use to build this? So the web UI you've been watching is a React client, and it's talking through the backend through AGUI. So I have a AGUI client SDK, consuming a server sent events, right? So chip cards, the state snapshot, all the things, the live update that you saw on the chat, that's AGUI.
Hmm.
And then the second client is that's the interesting one, is the any MCP host, Cloud Desktop, VS Code, anything that speaks MCP, they all connect to the same backend, just over a different protocol. We'll see that in a couple of slides. So on the backend side, I am using Node and Express. Um, that's one of the other key takeaways that I want for those who are watching this podcast, is that it's all MCP is language agnostic, so it doesn't really matter like if you're using Python or Java or JavaScript. So, and you do not have to be a Python expert in order to start adding AI capabilities to your application. So you can be a Java, you can work with Node.js or JavaScript, and you can still start adding AI into your apps right away, right? So now, anyway, so the agent engine, for that I'm using LangGraph. That's where the workflow lives. And OpenAI is what I'm using for the LLM provider, with the chat completions plus the embeddings that powers the search, for the places. So now two adapters are sitting on the graph. One is the AGUI adapter that is built on AGUI core and AGUI LangGraph. That is what bridging the LangGraph state into AGUI events
Hmm.
that the React app understands. And then the MCP adapter is the official Model Context Protocol SDK. That's what exposes my entire agent to external hosts. We'll look at one more example of a host. Like we'll actually use something other than the React app. And underneath, I'm using Redis for the holding the agent memory, both the working memory, the conversation state, and the long-term memory, the preferences. That's all held in Redis agent memory. Yeah, the thing I want you to work away from this thing is both the adapters that you see in my screen. They share the same underlying graph, same flow, same tools, same elicit decisions, same memory. The protocol changes between AGUI and MCP, but the rest is not changing. So we'll look at how this works. So here's the architecture. So I have a server which powers the web UI, as I just mentioned, plus any MCP client. We'll see another one in a moment. Now let me trace one elicit cycle end to end, just so that you have a mental model of what just happened in the demo. So first, user will hit the user's prompt will go to the agent. Okay. Now the agent itself runs as a LangGraph.js workflow with 3 nodes. The first node, I'm calling it context retriever, or just retrieving context. What it's doing is it's rehydrating the state from my agent's short-term and long-term memory in one single trip. The reason is agents are stateless. So each time you interact with the agent, it has to rehydrate the state once again. And it needs to happen in real time. It has to happen really fast because agent decisions are also made in seconds, right? So preferences, recent conversations, the current trip status, all of that is what I get initially, plus the user's latest message. Then once I have all the information I need, then I go to the next node, the actual planning agent. That is the LLM driven part. That's where the agent will pick tools. So I have a tool for checking the weather. I have a tool for updating the calendar, and I have a tool for searching just places based on whatever city you selected or whatever preferences, right? So the LLM will decide what tools to run, and sometimes it will run them in parallel. And then finally is the follow-up node when the user's response is incomplete, or let's say in any part of this process, some information was missing. Now, this is the node that's going to return the elicit in the form of the schema, the message plus the type schema. That's part of the graph's final response, the graph's final state. Then once that is done, the MCP wrapper takes over. So it's going to call server.elicit input with that schema. And then the client is going to render it in whatever shape and form it wants. Maybe it's a form, it's a set of buttons, it's an input box. Once that is done, then the user will respond, and then the reply will flow back. It gets merged into the agent state, and then the graph was once again re-invoked, right? Yeah. So, and my memory itself comes from my Redis agent memory, which itself is exposed as an MCP server. So that same memory layer is reusable across any MCP client. We'll come back to that in a minute when I switch hosts. Okay. So now here's the idea behind everything we just saw. When I was talking about schema, how does it look like? So schema is a contract, and then the server is going to adhere to this contract. So the schema language, if you notice, it allows for some data types or some primitives. You can define strings. You can define enums. You can define arrays, numbers and integers as well. If you notice this schema, it's fairly straightforward. No nested objects, no conditionals, no embedded HTML, and it's deliberately constrained. And then the client is now decide whatever client you use, that's going to decide convert this schema into whatever UI you use, right? Forms or chips or voice, whatever the client wants. Now this separation, the schema is what makes elicitation portable. Same server code, same schema, but rendered by any MCP client. So we'll look at that example. So the schema language is, for the form mode, is deliberately constrained. Strings, numbers, integers, booleans. No conditionals, no embedded HTML. The reason is, it can map directly to a form, and every a client that supports elicitation needs to build the form rendering logic just once, right? So that the trade-off is deliberate. Although it is not extremely expressive, but keeping the schema this way allows for implementation and adoption manageable for a broader range of clients, if that makes sense. More clients that can render the schema that you write. So if you keep it fairly simple, right? So every MCP host, you take, for example, Claude Desktop or VS Code, Copilot, MCP Inspector. Yeah, they all have like a renderer for the elicit create method. So when your server's elicit input lands on the host, the host just has to look at that schema and then load that renderer for that schema's type and then show the UI. That's it.
Yeah.
So yeah, so that's the thought process behind, I think, Elicitation. I think it's a very good design. So let me now show you. Actually, yeah, we'll look at an example. So you saw the UI, the React UI.
Mm-hmm.
Let me show you another one. Are you able to see this screen right now on my VS Code?
Yes, yes, yes. I can see.
Okay. Okay, so I'm gonna run the same tool on my VS Code, and we'll see what the flow looks like. So let me. So I'm asking the same thing. I want to plan a trip. I have to mention trip planning. I'm asking to use specifically this tool. The reason is sometimes the agent just doesn't know it has this tool available. So that's why I'm telling it. You have this tool available. Please use it.
Yeah.
Otherwise, it's gonna
This
do
is
a yeah
one of the classic problem with the ID most of the nowadays. Yeah, that's
yeah yeah
I believe
yeah.
everyone who is watching the podcast, they know
Yeah.
the problem. So yeah.
Yeah, yeah. So, but to make it to force it to use my tool, I'm just
Is it?
telling it. But the flow should just look it shouldn't really matter. But yeah, we just want to see what happens when we trigger our tool. So that's really the intention. So we'll wait and see what happens. Um, yeah, so so it knows that I have a tool. My tool, my agent is exposed as a tool in localhost 3000. That's what this JSON file tells my VS Code.
Mm-hmm.
Yeah, so I'm giving it permission to use my tool. So I'll allow it in this session. Yeah, so you can see going through the exact same process, but now notice the UI now.
Yeah.
So um, this is the part which I really want to emphasize on the interoperability, right? So the interoperability claim that I wanted to make very concrete. So we saw the React UI showed it as a bunch of buttons to choose from. VS Code is showing it also like a list of cities, and I can just maybe choose one. Let's say I choose Goa. Okay, and again same style, like it's asking me for the dates. If you remember from the demo that we just watched from the web UI, so I can actually enter my date. So let's say even if I make a type, let's say I enter it in a wrong format, then what happens? Let's say I enter it like this. So it's asking me to it's automatically the renderer in VS Code tells me that this is not the valid format. It has to be year, month, date format. All right, let me once again do this. I think the request timed out. So
Yeah.
yeah, okay. What was I was going to Delhi, right? Okay. So let me 2026. I'll travel during September, and yeah, all right. And then notice that the same thing with regards to preferences. The preferences, some of the preferences have already been pre-selected uh, in as you see in the UI, because we hydrated the state from the agent memory. So it makes for a much more meaningful, far more richer user experience. Like, you feel like the agent knows you, right?
Yeah.
Yeah. So,
That
and then
helps a
exactly.
lot. Helps a lot in simplifying the answers. Like now he knows that
Yes.
what I needed. So yes.
Yeah. Yeah. So, oh yeah, start date. Okay. I think I probably missed that. 2026. Uh,
While you saying this, that kind of selection also help agentic AI to revalidate the last information as well.
Correct. Yeah.
Like
Oh, yeah. All right. So now you notice that it got the list of inputs that the user gave as in a structured way.
Mhm.
So, and then it's given me a list of options to choose from. right? Now, like, I can even invoke the calendar tool. So, okay, add, I'll just, for an example, sake of example, I'll just add, I'll ask it to add these two places. Add okay, and then I want to show the URL mode, how that looks like in this client as well. All right, so it should give me a response shortly. All right, so it's done that. Now add my trip to my calendar.
Okay.
All right, so now we'll see how the URL mode, we'll see if that kicks in. Ah, okay. Oh no. This is sometimes yeah, an issue with it kind of does this whole rejects thing, like it gets it doesn't know that, it doesn't realize I have to tell it explicitly, please use this tool to add this to my calendar.
Yeah, that's what I'm talking about. So that
Yeah,
is a classic problem, but
yeah,
yeah.
yeah. I'll re-invoke it again. Please add use. It's going to go in on tangent. Use the trip planning tool to add my trip to my calendar. I have to tell it that way. So
We can
let's stop. Let me stop this. Yeah, to add my trip to my calendar. Right. Oh, okay. It didn't elicit. I think it already had access probably.
yeah, most
Oh my
probably.
God. Okay, I had to like check the logs. Okay, it's already added the trip to my calendar. Yeah. Okay, it's done that. So it's I think I gave it VS Code access in the beginning, but yeah, we can look at the calendar over here, so we'll see if it's added or not. Let me go back. Yeah. All right. So
Yeah.
it's I think it's added. Yeah, it added Museum Evolutions, Nature Trail Parks. Okay, I think it had access already, so it's went and added it anyway. So it didn't elicit the response. We can use this to indicate, well, it's only asking permissions when it absolutely has to, right? So it won't interrupt you constantly. All right. So now back to my that was it for the demo. So now architecture was done. We saw how it works in a different MCP host. Uh, Last short chapter. How do you build this yourself? How do you get started? So first thing, two things really matter, I think, when you're getting started. First, you need to identify what to ask. Okay. See, a tool can be, a tool can have the perfect schema, and it can still be a bad tool if it doesn't know what's worth asking. Like for the example that you just saw, it already had permission to access your calendar in from previous interaction, so it didn't need to ask it again. So I mean, before you even reach for schema, I mean, think about adding a bunch of code, figure out where the question is coming from. So there are three sources that feed behind every elicit decision for your agent. One is your conversation history, what has been said this turn or this session, right? uh, Second one is user state, preferences, past sessions, and then the third one is the prompt itself, like the slots that the user already has filled in with their natural language. So the elicit set, the set of questions to ask back, is approximately required information minus known information, right? That's how you can think about it. So if you get this part right, then the elicitation feels collaborative. Otherwise, it can feel very intrusive. It would feel unnecessary. So Interactive tools are the goal, elicitation is the protocol, and context, that is what makes the protocol useful. Okay. Now, context, where does that come from? That comes from memory, right? So the required input minus known input. Now, the question is, where does known input come from? The known input comes from the context, and context needs a place to live. It's also called the agent's memory. Now, there are two flavors of memory that we care about. One is working memory, another one is session memory. Let me show you an example of how that looks like. So I'm gonna show you the actual memory layer of our interaction so far. So this is what my memory layer looks like. So on my left, you can see the working memory. That is scoped to my current session. If you can see it, are you able to see the user and the assistant's messages stored in
Yeah.
order? Yeah.
Yes.
So this is the working memory. The user is right now planning a trip to wherever. They just pick the dates. They mentioned they want to go with their partner. Maybe all of that is in the working memory. So it's tracking what is in flight in this turn in this session.
Yeah.
Now, long-term memory is on my right side, which will persist across sessions. The user prefers window seats. Maybe they always pick museums and food tours, or they like staying near coffee shops. This kind of preference that won't constantly change. The agent has to bear this in mind. The user's preferences. It lives across sessions and compounds over time. So both of them feed this known information, the known set of the information, and this is what allows the tool, the agent, to not ask or elicit things it shouldn't have to ask. Okay. And memory has to be fast, fresh, and compounding over time. It has to clear these three bars if you really think about it. So why speed important? Because agent, the LLMs take decisions in sub milliseconds, right? So if the memory layer takes a lot of time to respond, the whole interaction will feel kind of a bit laggy. So the whole collaborative feel will not be there anymore. And it also has to be fresh. It has to reflect what the user said 2 seconds back. Otherwise, the tool will re-ask something the user answered. So that would feel a little bit broken. And it has to be compounding. Every session has to make the agent smarter, not just additive. It has to be genuinely compounding. Because the more your agent knows, the less it has to ask. So that's why I used Redis as my agent memory layer. It supports all these three properties for the elicitation to feel right.
And
Um,
even that compounding also help to ask meaningful, not just ask anything. Because
Absolutely.
the meaningful ask is also important. So that is what I see the compounding helping here a lot.
Absolutely. That's the 100%. Yes. So yeah. So the memory, the project that I use for this is called Redis Agent Memory. So what the other thing it can do is it can automatically summarize my working memory and put them into long-term memory. So that way, the agents will always see the most relevant context. Sometimes they don't need to know hi, hello, those sort of information. And then you also don't want to waste time and latency and tokens as well in feeding the entire set of messages right from the beginning all the way till the latest one. Sometimes you just need the overall context. So so that way your elicitation, your tool experience becomes a lot more faster. Now, the other tool that you can use when you're building something, you can debug with the MCP Inspector. Let me show you that as well. So this is how the MCP Inspector looks like. It's the tool to reach out for whenever you're developing applications. So you can look up tools, the list of tools exposed by this endpoint. Once it's connected, you'll know it's going to connect to localhost 3000, and that's where I've exposed my agent as a tool. So I can click on this and I can type a message over here, plan a trip, something like this. And it shows me a bunch of tool specific metadata as well. Now let's say I run this tool. Oh, 1 second. Let me reconnect. Yeah, okay. So I'm running this tool, and then we'll see what happens, what it gives ways. Yeah, okay. So it's giving us a structured um, response. Okay, this is based on the previous trip that I planned, and I added a trip to Delhi. So you can see that this tool allows me to inspect what is the structured content that is being returned by my MCP server. So pretty handy. And if, let's say, you start a new you kickstart a new session, you can also go into the elicitation tab to see what is the tool requesting for. So that's also supported by this inspector.
Yeah.
Yeah, so it lets you verify whether your server is emitting the right schema and handling the response correctly or not. So it's a go-to tool for if you're developing it. Yeah. So all right, I want to close in on a thought. The tools that ask clarifying questions, they aren't new. Okay, the pattern has existed. I mean, not the MCP part, but the overall pattern of eliciting, involving humans in the loop, that has existed for a while, if you really think about it. So one is, if you have ever done a get rebase, an interactive rebase, what happens? So it opens an editor mid command, right, and it asks you to clarify the rebase plan before continuing. So that way you feel more confident about destructive operations, right? npm init, that also walks you through fields one at a time. Each value is typed, validated, and surfaced. So that's IDE style, been there since 2010, I think. And then OS permission dialogues. Like before I started recording this, before we started recording this podcast, we're doing a screen share. It asks you and elicit. It elicits the user if the app has permission to access your camera. Does it have permission to send you notifications, or does it have access to your audio input and whatnot? So the app is mid execution, the system is pausing, the user is making a decision, and then the app is resuming. So same negotiation, right? Now we have now doing this in the world of AI using MCP. So what MCP elicitation is giving is a typed, portable, schema-driven version of that same pattern, usable by AI agents, and renderable by any client. Okay. Yeah, that's one thing to think about. So four things, key takeaways. Yeah, MCP elicitation, that turns a tool call from a one-way request to a two-way conversation between server and user, bi-directional protocol. And there are three workflow categories where this strategically pays off: ambiguous input, missing context, authentication flows. Second is the server commits to the shape of the response, the client picks the UI. That makes elicitation very portable. And form mode and URL modes are deliberately separated. Credentials and payments should always go via URL mode. Don't try to use form mode for that. And yeah, fourth, the last is context and agent memory is what makes elicitation genuinely useful. Elicitation set should be required information minus known information. You don't want the elicitation to feel like interrogating, right? So context will allow, it will save under informed agents, so that's how elicitation works best, when context gets more relevant, personalized, and informed by past interactions. So which is why we saw the agent memory side of it as well. Yeah, so closing thoughts, the next few years of MCP are going to be very good. Like this elicitation has been part of the standard spec, I think, since November last year. I think some of the clients are still in the process of adopting it. I think Cloud Desktop does not support URL mode yet, as from at least at the time of recording this podcast, I think. But yeah, I think once this is becoming more and more mainstream, every chat host every chat host is gonna start supporting it. So here's the question that's going to separate the apps that people love from the apps that people just put up with. Does this app feel like it's collaborating with me, or it's just like a black box that either it will work or it will not work? So that's the line that these design patterns will let you cross. So yeah, what you can do after watching this podcast is, maybe if you're developing an AI agent, maybe pick one tool, maybe in your MCP server, find the moment where it's currently guessing or failing, or and then try to replace that moment with an elicit, and then watch the user experience after that. That's how you start building it anyway. Yeah, thank you for having me in this podcast. Yeah, I'm available on across these socials. If you have any questions, I'm more than happy to take them. Elicit me on any of these channels. Yeah, that's it.
Thank you, Ashwin, for that. But I won't let you go for now. I have really three questions to ask. So I
Sure.
note down one is around the schema, which is I believe a lot of people have in their mind. So the schema is deliberately simple from a developer point of view, but why it is why it is a limited schema better for the interoperability.
Mm.
Yeah, so that is actually I need to understand.
Yeah, sure. Yeah, I guess I touched upon it briefly in the thing, but it's a great question. So, see, a limited schema, it goes back to the. I'm sure if those of you who are watching this, you probably know who Tim Berners-Lee is, and he coined this term, principle of least power, like least privilege, not least privilege. It's basically like use the choose the most the least powerful programming language for the task. uh, there's a good thought process behind it. So see, a limited schema is better for interoperability because every MCP host has to render it. Like
Yes.
not just our host, like not just the server who has authored it, but every other MCP host. That's really the point of having MCP in the first place. You want your server, your MCP, your tool, your agent to be used by other systems, and vice versa, right? So if the schema language becomes too expressive, then every client team has to build a much more complex renderer. And we are in the age of move fast and break things, and
Yeah.
many of them will just skip doing that. They'll probably not, they'll think of elicitation as an afterthought probably. So the constraint model is a deliberate way. It is of course not very expressive, but it has a better chance that the same flow works consistently across any client, like we just saw, right? That is, I think, a good trade-off if you want to balance. You want portability instead of just per single client customization. So, yeah.
That's great. That's great. And one more question I have is for like for someone just for one tool. So for someone is already building MCP server, and if they need to, if what is one tool they should improve first using elicitation?
Hmm. One tool. Okay.
Yeah, just one tool.
Um, I mean, if you're in the process of learning, there's a bunch of. I mean, you could use.
Just one tool which you feel like they should improve first. Use as soon as they start working with elicitation.
Okay.
What is the one tool you think is going to help them?
I think wherever I think one key part where it really I mean it just really pays off. I think maybe think of it like as any tool that is trying to access do something destructive. Maybe like let think of a deployment tool.
Mhm.
Maybe that's a good example. Because it will combine missing context. Risky execution is also there. Like if you're trying to deploy, there's a deployment tool. Let's say you might have a need for confirmation or preview before something irreversible happens, right? Now that is where elicitation can actually show its value immediately. The tool can pause and clarify. Let's say you're trying to deploy an app. It can clarify, is this the target environment? Are you sure that this is where you want to deploy it? You want to ensure that before you deploy, your tests have passed or not. So maybe the tests have failed, and it wants to tell the user that no, are you sure you want to deploy it because some of your tests are
Yeah.
failing. So any destructive operation, I think that's like an immediate value add. So show what it's about to do and only continue if the user is saying yes, okay. So I think that's probably a way of more useful way of developing with MCP than just having a thin wrapper around a read only endpoint, I think.
Yeah.
So yeah.
That's great. That's what I understood is, I mean, from your explanation, if simplifying my as an architect perspective, is anything that is going to touch a tool should make sure it's understand authentication, authorization, and
Absolutely.
accountability, what it exactly is going to do. Once
Yeah.
these are the parameter managed in the tool, then yes, that is the first thing I think I will improvise for that. That's
Yep.
great. And because now we're talking about a lot of how is things is, let's talk about one of thing we should avoid. So what is
Okay.
the one mistake developers should avoid when they're building the interactive tools?
Um, Maybe one mistake that I can envision is yeah, again, like treating elicitation like interrogation. Like asking for every information upfront is also not necessary. Sometimes the user just wants to, let's say in this trip planning agent, maybe just they just want to browse. It would be like in terms of experience, you would have gone to a shopping store, maybe like a clothing store, and you just want to browse. But it would be annoying if I'm sure all of us had this experience, like, we're at a clothing store and then we just want to see what's there, like,
Yeah.
and then but then one of the staff comes and asks you, what are you looking for, what are you looking for? I mean, maybe it's okay once, but then if they keep asking the same thing, it just feels annoying, right? So
Yeah.
so to this, so coming so the analogy, what I'm trying to say, what I'm trying to link that analogy with this conversation is, as a good interactive tool should ask for what is actually missing at the moment it becomes necessary. Okay,
Mhm.
at the moment it becomes necessary, and then get out of the way. If you over elicit, then you lose the conversational feel. You're back. It feels like a interrogation. So in my own flow, in my own work, this is where, like, I use this is where agent memory becomes super critical. That becomes very, very useful. The system has the right session context,
Mhm.
past decisions, user preferences. It need not ask again. Like, the goal is not to maximize the number of questions being asked. It is to ask the minimum useful question, and then use the memory layer to keep the interaction moving naturally. So yeah.
That's great, Ashwin. I mean, I know it's a very long discussion and one of the most interesting topic. Nowadays, people really need to understand how actually MCP will improvising. So that was a really practical conversation because the future of agentic AI is not only about smarter models, it is also about better interaction design. Tools should not behave like black boxes. They should collaborate with like users, ask what they need, and continue safety. So this is where the MCP elicitations become powerful, like you already explained a lot in details.
Absolutely.
So
Yeah.
yeah, so that helps to keep your role simple. Um,
Yep.
so thank you everyone. Thanks a lot for going through all of this information. And if you have anything to ask, Ashwin details is already shared on the video. You can check the description we have, and please connect, ask anything. We'll love to answer for all the questions. And
Yeah.
thanks a lot, Ashwin, again to joining us for this long podcast.
Thank you
And
so much. Yeah. Pleasure to be here. It was fun. Yeah. Thanks
okay,
for having me.
okay, thank you, Ashwin.
Thank you. Yeah. Have a nice day. Bye.